Chapter 2.8, Proportions and Similar Figures. You're going to use proportions today, and you're pretty good at solving proportions, so you should do a good job. Your objective for this lesson is to find missing lengths in similar figures and to use similar figures when measuring indirectly. Before we can start the lesson, we need to talk about what similar figures are, and similar figures have the same shape but not necessarily the same size. The side lengths of similar figures are proportional, which is going to help you when you're trying to find the missing sides. So for example 1, they have to tell you that the figures are similar, and that's what this symbol means, is that this triangle is similar to this one. And that's pretty much telling you that the side lengths are proportional, so corresponding side lengths are proportional. They ask you for DE, so they want to know this side here. So I can use the proportion 10 over 16 is equal to x over 12. It's like you're matching up the sides that are congruent. So 10 over 16, this side matches this one, so I'm going to do this side over 12. So my proportion is 10 over 16 equals x over 12. Then you'll just do cross product, so you get 120 equals 16x. Divide both sides by 16, so x is approximately equal to, actually it's exactly 7.5. So DE is 7.5. Guided practice number 1, they want to know AC, so they want to know this side down here. You have these two, so you're going to set it equal to these two, and you're going to make AC be your x. So set up your proportion 12 over 18 equals 16 over x and solve it. I'll give you the answer in just a second. Alright, 12 over 18 is equal to 16 over x. Cross products are equal. Solve, and for guided practice number 1, you should get 24. You have to show all of your work. If you just have what I have written, you're going to get it wrong when I check your notebook. Example 2, applying similarity. The sun rays strike the building and a girl who is 5 feet tall at the same angle. The shadow of the girl is 3 feet and the shadow of the building is 15 feet. How tall is the building? So I've got a girl and I've got her shadow. Then I've got a building and I've got its shadow. And they create a triangle. Okay. The girl is 5 feet tall. Her shadow is 3 feet long. The building is what we're looking for, the height of the building, but we know the shadow is 15 feet long. So we're just going to set up a proportion. 5 over 3 equals x over 15. And we do cross products, and we get 75 equals 3x, divide by 3, so x is 25, which means the building is 25 feet tall. Guided practice number 2, a man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet. The shadow of the flagpole is 17.5 feet. I'm going to draw you a picture, then I want you to solve it. So the man is 6 feet and his shadow is 3.5 feet. The flagpole is, we don't know, and the shadow is 17.5. I want you to set up the proportion and solve it, and I'll give you the answer in just a second. Okay, so that's going to be 6 to 3.5 equals x to 17.5. Cross products are equal, and when you solve that proportion, you should get 30 feet. You have to show all of your work, not just what I have written. So do all of the work for that and then put the answer down. Example number 3, interpreting scale drawings. This is like when you look at a map and they have a scale on the map. You need to be able to go from the scale to the actual distance. They want to know the actual distance from Jacksonville to Orlando if on a map they are 1.25 inches apart. Use the scale 1 inch equals 10 miles. That's not actually supposed to say 10 miles. That's supposed to say 110 miles. So we're going to go 1.25 inches equals X miles if 1 inch equals 110 miles. We'll do cross products. 1.25 times 110 is 137.5 equals X. So my answer is 137.5 miles. Guided practice number 3. The distance from Jacksonville to Gainesville on the map is about 0.6 inches. What is the actual distance? We're still going to use our scale that we have up here. 1 inch equals 110 miles. So 0.6 inches equals X miles if 1 inch equals 110 miles. And we will do cross products, and you solve the whole proportion on your paper. But what you should get is approximately 66 miles. Alright, last example. Using a scale model. A giant model heart is 14 feet tall. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man who is 6 feet tall to be? So 14 foot tall heart goes for a 170 foot tall man. If I have a 6 foot tall man, how tall should the heart be? So we'll do cross products. 6 times 14. I get 84 equals 170x. Divide by 170. And I get 0.49. And it's approximately equal to, because I rounded. And that's about a half. So it's going to be 0.49 feet, and you can convert it to inches, and that's 5.9 inches. Okay, guided practice number 4. Pause the video, do this one on your own, and I'll give you the answer in just a second. Alright, the scale model of the building is 6 inches tall. The scale of the model is 1 inch equals 50 feet. How tall is the actual building? So 6 inches is X feet if 1 inch equals 50 feet. So we'll do cross products, and we get X equals 300 feet. Here's where you get to show me what you learned from the video. If you can't answer these questions, you need to go back and watch the video again. For number 1, I need you to find X. So you're going to do 7.5 over 18 equals 5 over X. You have to show your work. For number 2, I need you to find Z. So you're going to do this over this equals this over this. And you have to show your work. Number 3, you have a scale of a map, and I need you to tell me the distance between two towns that are 3 centimeters apart. Show all of your work and bring it to me tomorrow for proof you did your homework.